Welcome to the second part of the journey. On the last video, we stopped at the end of March. So, let's continue. PLI has a tendency to deform in time, which means I need to find a way for this structure to not bend in time. And here I've got the under part, still with 6 opposing magnets. It did not help. It made it worse. The pair of magnets were attracting each other, not repelling. It's making it even wobblier. So I try to remodel this. This is the next one. We've got the base, which will not move, and the upper part now it's pretty limited, but it works pretty well. I like the feeling. I like the resistance it adds. It uses magnets to make it harder to go at the end of the run in every direction. I kinda like it. On this design, I've got 8 improvements I'm going to do. First, this part right here is too fragile. It bends when the screw goes in. The gravity allows for the down motion to be easier than the upper motion, which needs to be fixed as well. I'm going to allow for more movement in every direction, approximately I think 1 millimeter in every direction. The outer shell is squishy, it needs to be sturdier. It looks like it's everything. I really like this one. Pretty nice. That's it. Hey ho. I've done some improvements. Why am I making this project? The answer is to have a better experience designing. So I came up with another idea. How about having the multi-directional cube on the top right of Fusion 360 physical? What if I have like, let's say, a platform, and I don't know, some things more. I might enjoy the idea. And yeah. Now, I improved quite a lot the movement. It can move way more than before. It's pretty nice from the top. And one thing, the bottom holes for the magnets are just a tiny bit too large. And look at this. What can I do with this mistake? I enjoy the sound it makes. So why not making it a sound feedback from the rotation or the movement? Not from all of them, because I don't know, it feels quite janky if all of them move. But what if just one of them does this when I rotate it? So, because right now the motion doesn't have any feedback, like the older mouse. Interesting. It's just interesting. The system from the paper works really well. Welcome back. I've got some news. Some good news. So, I got contacted by PCB. And you know why? Because fuck buying PCB. How do they fucking work? Top side or bottom side? I don't fucking know. What the fuck is this? Bore cleaning? Bake components? Luckily, they did not take it seriously. But I stand by what I said. As an example, I think the project from Amaville is impeccable. But the problem is trying to figure out how to buy the PCBs. Probably at the time the services didn't have the feature to upload the entire project. So this is what I'm going to do. I will still make the GM2 entirely 3D printed without any PCB required because I want it to be accessible to everyone who has a 3D printer and a soldering station. In parallel, it would be nice to see how it can turn out if I use their services, which means probably not using PLA or PETG, but I don't know, metal printing and PCBs as well. And in the end, to upload the project from the PCB way services to the end goal to have two versions of the GM2. The one with the PCB and probably metal printing will be available to buy entirely from their website, so you can buy the entire project without any tinkering of the specifics. But there is one condition: both GM2 has to have the same functionality. The difference will be all inside and the ease of construction. I am in a compliant mechanism rabbit hole, and I intend to go even further. Probably even making an entire video about it. Right now I've got two papers investigating. Design of a triple crossed flexure pivot with minimized parasitic shift. I'll post it down below. And the other one? Oh, and the other one I've said it in previously. Let's start with the first one. This is the prototype for another compliant mechanism. You can see the parts that bend, the strain relief. It still needs a lot of time to be examined properly. I'm still not sure how to use it, but I will. This is the prototype as of right now. I have the gyroscope on the top, the magnet sensor on the bottom. It has quite a lot of clearance for moving in 6 degrees. Both the magnetometer and the gyroscope are connected to the SDA and SCL pins. It feels quite nice. It's still a bit wobbly. Then I was thinking, I've got a triangle with each pole 2 magnets and a lot of opposing non-moving magnets. Is this optimal for the sensor? How do I even test it? Vadim! Okay, it's a start. It's a start. And that's a magnet. And you can see, if I get the magnet close, it moves. It has the directions, and up and down. And as I can see, one magnet moves way better than the array of 8. So I guess it's clear. I'm gonna use only one magnet. Okay, I've got some improvements. A whiteboard. Let's start with the original design. Pretty clever, I like it. But we are doing it in plastic. Which means, in my opinion, we need to change the shape. I've tried full strength, which means no slim parts. 2/3, 1/3. This is the original design. And this is my design. Why did I do it this way? Because in plastic, moving this part, we have the rotation, which is pretty easy, which means this part. The up and down, same, but this type of movement has some issues. And looking it in PLA, which is the most resistant one, but it shows me easier where is the problem, I found that this part here is the most problematic one. I don't know why I did an arrow. But this is the part that blocks this type of movement. That's why I did this. That's it. Thanks to PCBWay, I was able to try 3 new materials. These 3. The quality is pretty nice. Flawless, if I have to say. And I think I'm going to see the weight difference. Just so I have an excuse to use my favorite scaler. My coffee scaler. Because I love coffee. Oh, I do love coffee. The power of editing. These 3 are the PCBWay materials. This is PLA+, PETG, and PC. Apart from PLA+, all of them can be used for the mechanism. It depends on how tough we want it to be. And on the shape as well. But using the original paper shape, we've got this difference in strength, in resistance. This one is the hardest to move, this one is the easiest. I weighted them as well. I don't know why, but it seemed fun. For the ease of use, I'm going to use PETG. But the version using the PCBWay services will probably be HPPA12. I'm still trying to define the entire GM2 shape. I'm taking inspiration from a great inventor, Wintergatan. On one of his videos, he tries to think of the position of every piece with cardboard. I'll do the same. I'll try. I would really like my new GM2 to be a platform for designers instead of only a joystick. And right now I've got the navigation knob, the wrist rest, still not designed, a home cube, a numpad, and shortcuts. I will still use an Arduino Pro Micro as the main board. Connected to it right now we've got a magnetic sensor under it, and ITG MPU gyroscope connected in parallel to the SDR and SCL pins. I will probably need a big grid for all the buttons. Buttons? How do British say this? I will probably need a big grid for all the buttons. Hey, I'm the sponsor of this video. I don't need to explain you how my services work. If you are on this video, you sure are a smart human. And since only a few will be brave enough to watch the entire video, I've got a $10 coupon for a $30 purchase. I've only got 10 coupons, so you better get them. Go on my coupons and type RATSPCBWay. You're welcome. E quindi nel mio skit praticamente urlo Vadim, vado da te e ti do una bottiglia di Kong Strong, ho pensato. E tu mi dai dietro il programma.
Diventa gli Scooby Snacks.
Esatto.